Starting with question 1, we are asked to find and plot daily revenue. So what I did, I took these numbers right here, monthly volume divided by 30 to make it into daily volume. And then I multiplied it by the price, which gives you each of these daily revenues. And I plotted those compared to their respective ticket prices. Question 2, daily concession revenue. I actually just took these numbers over here and plotted them against ticket price right here. Obviously, when the tickets are free, there's going to be a lot more in concession revenue because people can spend that money elsewhere. Question 3, daily total costs. Kind of same thing right here. We have daily volume and daily total costs. And so I plotted daily volume on the x-axis because that is the factor that changes, and cost is what correlates to the change in daily volume. Question 4, the fixed cost. Going back to question 3 real fast. I chose a linear. You could potentially use exponential, but I chose linear just because, generally speaking, this is pretty linear. Obviously, we see a slight jump from here to here, but I think linear is sufficient to basically describe how your cost will increase at a linear rate. And with that, finding the fixed cost, it's simply just this 692.54 from our cost function. So the fixed daily cost is about $692.54. Question 5 says use total revenue and total cost functions to determine what price maximizes profit. So right here, I listed our prices. I listed the daily costs at each of these prices, the total revenues at each of these, which is a factor of concession revenue and daily ticket revenue at each of these prices. And then I simply just subtracted the revenue from the cost. Also, one thing to find the cost, I used daily volumes, which I took monthly volumes divided by 30 to give you daily volumes, and that is what I plugged into the cost function for this x right here, which gives you these costs. At $0 ticket price, we would have the $722 of profit, which is the maximum. Obviously, there's some things we'll go over down here that might dispute that. But question 6 just asks us to essentially plot the theater profit at various prices. And so you can see that you have the profit high up here, and then at about $1, you're barely making a profit. And depending, I think if you use the exponential for your cost curve, you might actually even be making a loss. But then you can see for the rest of them, you're definitely making a loss past $1.50 and beyond. And then question 7, it's asking you, if you're the manager with the objective of profit maximization with just this information, which ticket price would you charge? Obviously, the simple answer is to make the tickets free because you'll make the most in concessions. But then question 8 says, what other considerations beyond this analysis might be relevant? What I said was the biggest consideration I noticed is that the theater might not be able to hold enough people at the free ticket price. While the profits sound nice, the theater might not have the capacity to hold as many people as the demand function suggests. So you might need to set the price at a point such that you can maximize profits at the supply that you have available, if that makes sense. So if there's, let's say, daily demand at $0 is 1,000 people, I'm just using hypothetical numbers, but your theaters can only fit 500, then you're not going to really be maximizing profit. And so you might as well charge a little something so that you can use one of these numbers instead. Question 9, what industry structure is the theater operating in? So this is best described as an oligopoly because there are only 5 competitors, and what these competitors do is going to affect each other. If one has a cost advantage on concessions or something, they can make a little more profit than competitors at these same prices, but generally speaking, it's not like a hyper competitive market because there's only 5 competitors. So because there's only 5, it's an oligopoly, and there's not much differentiation or anything like that either.